Hello, welcome to another episode of Learning sCrypt tutorials. In this video, I'm going to show you how to maintain state in an sCrypt contract. As we have introduced earlier, Bitcoin smart contracts, and by definition, sCrypt contract uses so-called UTXO model. And UTXO model, by default, it does not keep state and is usually referred as stateless because once a UTXO is spent, it's destroyed and it's gone. There's no state that can be maintained. However, we can build states on top of the UTXO model, as we can see from this graph. So the basic idea is we can store state into the locking script of a Bitcoin transaction output. And then as we keep spending from the output, we can mutating the state and put a new state into the new output and then keep going. So in this example, we have three transactions. It's transaction 1 is spending from 0, transaction 2 is spending from transaction 1. So at the beginning, the state is initialized as 0, and when transaction 1 is spends transaction 0, the new state becomes state 1. And then the same thing happens when transaction 2 spends transaction 1, the state goes to state 0, 2. So how do we make this happen? Let's look at one simple example. So in this simplest stateful contract, what we do here, we maintain a counter. Basically, this counter just records how many times the public function increment has been called in this contract. So how do we do this? We do this in two steps. Step 1, we denote any property that we want to maintain as a state. Basically, we want to persist it across UTXOs. We use this so-called state decorator. So it's denominated as @state. Then this counter is an integer that's a stateful property. So once we declare that, this becomes a state, and then you can use it as any other type of property. You can use this .counter to access it. You can read it, you can write it, and you can also use it as a argument for any function call, for example. So basically it becomes like any other property. And the second step, as we have shown in the previous graph, you need to persist to propagate this new state into the new output. And for this to happen, we use a output transaction technique we introduced before. So again, we pass in the transaction preimage. We check it is for the current transaction. After this, so here is the part we can take a look. First, we call this function called getStateScript. Basically, this returns the locking script that contains all the stateful properties. So once we have this is the output script. We can use the output transaction data. We build an output from it, and then make sure this output is indeed the output for the current transaction. So this simple contract can can record how many times increment has been called. So let's try it. So let's try to deploy it on testnet. Then we can click again, say deploy. We can initialize it to be, let's say 0, and then we deploy it. Okay, now it's good. Again, from the deploy panel, you can go to the very top. You can see this has been deployed and has been initialized to 0. So we can call it. And at the same thing we have down here, we can add an output, which is a stateful output, because we are going to persist the state. So we can, and since it's 0, and we only increment here, right? So here there must be 1, right? And then we fill in the same push transaction data here. Basically, this must be the same with whatever the output amount is. So let's try to call it. Oops, and it turned out that's an error. Basically, this means the fee is too low. So let's actually increment this to be, okay. Now we have increased the fee to be 2,000. Hopefully this is good enough. Let's rerun again. Okay, it passes. And then the counter now has been updated, the state has been updated to 1, which is expected because we only increment here. So as we mentioned before, we can keep calling it. Let's keep calling it again. And this time, let's do one experiment. Actually, instead of increment 2, right? Let's see if we can force it to be 1. Again, we use a fee rate of 2,000. So this is now use. Let's call it again and see what happens. Okay, not surprised. Not surprisingly, this fails because the current counter is 1 and we are only using 1, so it's not incremented. So we have to use 2 here. Let's try this, run this again, and it successfully updates the counter to 2. Okay, which is expected. So we just showed you one example how to maintain state using sCrypt, and by using this state decorator and using the opt push transaction technique. So lastly, I want to briefly show you how you do this in the SDK as well. So the same thing here, you can use the new syntax to initialize whatever property, just like stateful property, just like you are initializing any other type of regular properties. You can use the new syntax. For example, here, I use the counter 1,000, and then when you are ready, you can compute the new get state script. Basically, you are computing the new locking script that contains a new state. So new state, we just put 1,001 here because it's incremented. After that, you can put it into the transaction output as we did in the contract. And this is how you also interact with stateful contract in our sCrypt SDK, JavaScript. So I hope this is useful, and I will see you in the next video. Thank you.